Welcome to Insight Builder channel, artificial intelligence automators, Python experts, and my dear friends. Revolutionize ML predictions with Towhee pipe module. 7 nodes that automate predictions with AI models inside Towhee. The difference between pipe and data collection. If you are new to this environment of LangChain, Towhee, large language models, and artificial intelligence models, you might be wondering, okay, what is data collection, what is pipe, and what am I talking about? So if you are totally new to this environment, do visit my playlists inside the Insight Builder channel, and you will see that under the playlist Mastering NLP with Hugging Face, I am considering not just the OpenAI models, but also various other open source models that is available in Hugging Face. In the playlist, in the last 2 videos, I have been discussing about the Towhee module, the Python library that can work with multiple AI models, not just the vision model or the text model. It can work with multiple different modalities and multiple different models. And in these videos, I discussed about already pipelines that you can establish using data collection objects. However, in this video, I am going to talk about working on pipe module and creating again pipelines. So there are 2 ways to create pipelines. So that's what I wanted to make this clear in this video. So first method that we have been discussing is data collection API. So we can create pipelines using data collection API. And these data collection API pipelines can be run efficiently inside local, smaller powered, lesser powered systems like your laptop or your local server. However, when you're going into production, which is going to work with huge amount of data or streaming data that is going to come from the customers, then it is going to be better to work with pipe module, because the way the pipe module is implemented inside Towhee and how it interacts with the data, how it interacts with the machine learning models is done with directed acyclic graph. Okay, so you may not be aware of what is DAG or how it is going to help you in improving your real-time works. But one thing that I can make your life simple is that when directed acyclic graphs are used, the processes that is done inside is segregated across multiple nodes or multiple processor nodes, and the tasks are executed. In that way, you can do multiple parallel processing also. Yes, you can do the same thing in data collection API, but in case of pipe, this implementation is much better. I'm not going into the nitty-gritty details of how the pipe or data collection is implemented. However, our intention is to understand the various nodes that is in pipe. That is my primary intention. Okay, so I am giving you a brief background, because if you are going to discuss with someone in your team who is more senior, or if you are going to discuss with the developers and trying to convince them to work with pipe module instead of data collection module, then this particular video is going to give you an overview. So you have to watch the earlier videos also to understand the data collection API. But what I am trying to do is make your life easy in this video to not only introduce this 7 nodes that is available in pipe module, but also I will be giving you a brief comparison between the pipe module and the data collection module at the last, right? And this entire code that we are going to discuss is inside GitHub repo. I will be giving you the link of this repo that I am showing here, and you can always go there and start practicing by pulling that repo. Again, all these videos are created for you to not only to watch, but also to share it with others. The technology that we are right now that I am right now sharing with everybody is related to open source. The purpose of open source, as you guys know, that we all work on it together and grow along with it. That is the primary intention. So do share it with others, and I hope that you like my content. Do like it and also subscribe to my channel. I'll be working on further videos in Towhee where the text searching, image searching, and also exporting the data to Milvus data collection or database will also be discussed in the coming future. So do subscribe so that all these video updates will come directly to your YouTube dashboard. With that said, let us go to the browser. And this is the playlist that I was talking about, so you can explore my other playlists inside this channel also. The repo that I was talking about, the notebook that we will be working on is this particular notebook that is already inside the GitHub repo. So you can use this notebook and start working on that. All you need to do is copy this particular link, come to Google Colab environment, and you have to come to Google Colab environment, and inside the Colab environment, all you need to do is say upload notebook and go to GitHub option, and then present your the link that you copied from the GitHub repo, and you will directly start getting this particular page. Once you start getting this particular page, all you need to do is start executing it, and you will start. Okay, before you execute it, you also need to get this data, the Cloud Dawn, these 3 images. That also you can get it directly from the unstructured exploration folder. So it is already there here. So you can get these images and also download it and then upload it here. All these images were taken from Pixabay. Leave a thanks to the Pixabay guys for these images. Let us start working with the module. So in this particular notebook, I'll be primarily concentrating on Towhee module only. I will have some discussion regarding pandas data frame. So I'll be showing that in a couple of minutes. Okay, so let us begin the process. So all you need to do for getting the Towhee module installed is that pip install quiet Towhee. So execute that, it will start running this particular notebook. Go ahead and run it. And again, Colab notebook is a virtual instance that is provided by Google, and you can see the details. It's around 13 GB RAM and 100 GB machine that has been provided to us. You don't need any GPU for running Towhee, so you don't need to worry about that. The models that will be getting pulled by Towhee also, most of these models you can work with regular CPUs. Yeah, if there is going to be high huge models like Llama, or if you are going to work with huge models like Facebook, ResNet is very small model, but there are models which is crossing 6 billion or 12 billion or 24 billion parameters. For those such models, you will need GPU, but whatever we are going to work is very small. Okay, coming to Towhee again. Here the module that we are looking at is inside. So the pipe module is inside Towhee.dc2. So you need to import the pipe module, and again you need to import Towhee.dc2 ops module. This ops module has to be from this Towhee.dc2. If you try to import, so you can also import directly from Towhee also. So if I go here and if I execute that, okay, I don't want it from DC2, but if I want it from ops also, you will see that this gets executed. So there are 2 ops module. One is inside DC2 and another is outside DC2. So what you need to use is what is inside DC2. If you use something that is outside DC2, your code will error out. Keep this in mind. Coming to the first and foremost important nodes, 2 important nodes, the input node and the output node. What you need to understand when you are working with pipe module is that it actually works literally like a pipe. So you send it's like a function in regular Python. Okay, let us look at a regular Python function. It will be much easier for you guys to understand what I'm trying to say. So let us take a regular Python function, and if I will create it with a name and name P. So I'm not giving, okay, let us make it P1. Okay, so it will be a little better that way. So I'm going to create a simple Python function called P1 with the argument called num, and I'm not going to do anything else. I'm just going to say return num. So what do you think this particular function will do? This function is not going to do any kind of modification. So if I say p_1 and if I give 15, the return will be, the answer will be 50. So that none of the process is getting executed. But you see, in this case of this function, there is no any kind of additional data structure that is getting created. Whatever number you are giving, the 50 is the integer type that you are sending into the function, and out comes the integer type. Okay, you can do some kind of modification in here, like when you're returning, you can try to say, I don't want integer, I want to make it as a string, and you want to return it. So if I now execute it, the output will be a string. So you will see it is coming with a double quote inside the quotation marks. In the same way, what will happen in case of pipe module is that you can name this, instead of num, you can make it as n also. You can make it as abc, whatever value you want to provide. So it will act as a simple function the way I showed you here. However, the difference is that, for an example, I will execute this and you will see that this will work as a pipe module right now. So here, once I execute the same thing, so here the pipe name is p1, and I'm going to execute this as res equal to p1. I am going to show you the reason why I'm splitting this code is I want to show you the type of the variable that is getting created. So the type of the variable that is created is data queue inside Towhee pipeline, but whatever you are going to get created here in case of the regular Python function is simply a function. So it doesn't have additional activities that you can do. So okay, what kind of activities that you can do with pipe module? So how to find that out? Very simple. Once you start creating pipe related objects, you can use dir command and try to execute it on the object. So you see that what are the things that you can do on this object. So you see there are lots of additional methods that this the data queue object has got. And also, if you try to do the same command on pipe module, you'll see that pipe module has got various, these are the various nodes that we are going to talk about. And if the same thing, if you do on data collection, so I think I have not imported data. Yeah, I have imported data collection also. Towhee.data collection, I have done that. And I will show you what is possible with data collection. Data collection is much bigger. See, as I was telling, the pipe module has a very different objective. The objective of this pipe module is to make your work easy when it comes to working with massive data sets. Okay, when in case of data collection, it's more about prototyping, and you see the methods that is available with data collection. You can find it out. So this is a brief comparison that I gave it to you guys. So just give me a moment. Now that you have got a fair idea about data collection and pipe difference, what I'm going to do right now is that what you can also, that is one more thing. You can wrap around the pipe data queue around data collection. After that, only you can get the data out of the data queue. So this is one of the points also I wanted to highlight. So you see here, I created the pipe object here. This is a pipe object, the data queue pipe object. Once I created that, I need to wrap it around data collection, and then I need to call the show. Once you convert that pipe into data collection, then only you can see the data that is inside. So this is also one of the points. When it comes to Towhee modules, it has lots of inbuilt features like lazy evaluation. It can work with streaming. It can work with various iterator modules that is inside Python. So a lot of things I had covered in the earlier videos. So all these things are possible because of the data collection object, right? Next, what you are going to do is, right now we saw that we can work with single variable, that is a simple integer variable. If you are going to send in a list, so into the same pipe, so I'm not changing the pipe here, so I'm just sending in a list. What I will get out is again a list object, but inside the data collection object. So you will wrap it around data collection object, and you will see that the output is 1 2 3 4 len equal to 1. Now think about the output that you might get inside this particular function. So you send a list inside. So for an example, if I wrap it around like this, and if I say 5809 etc., and you request the output, what you will get is, first of all, this will error out. Okay, because I am actually trying to convert the list into string here. Immediately it will error out. However, you saw in case of the pipe module, we got an output that is completely different. This is because that we are working, the pipe module has various other internal implementation that can work with list object also. So you saw the difference, right? The reason why I'm comparing and contrasting is that you can understand it much easier when you are working with multiple different methods of solving a particular problem. Pipe solves a problem. The problem that it solves is that it can work with the tabular data, work with collection of data like list. It can work with pandas data frame also. We'll be seeing how it works. So the regular function, if you have to make it work, you have to do a lot of additional coding. So, and also it works with various operators that can pull in artificial intelligence models, open source models from the Towhee hub. So let me show you the Towhee hub also. Just give me a moment. This is the website where you can understand about Towhee hub. And if you go into operators, you can check the documentation. The documentation is pretty exhaustive. And if you go into operators, you will see a lot of models that is available, not just for NLP. It is available for multimodal. It is available for vision. It is available for audio. You can briefly look into these models and you can understand how it is getting pulled in. So if you go into any of these modalities, you will see that it is there are various models, there are operators, and there are the model names. These are the various model names available. If you click on any of the model names, you will see a brief write-up and also a code example. And the code example will work on the pipe module. This is what I was trying to say, and this is the primary reason I am introducing this pipe module to you guys. Because once you start working with working with real world data, and you are working on a ETL pipeline that is involving the AI models, then it should be easier for you guys. Towhee makes it extremely easy. See, I will be showing it to you what happens in a moment, but this is the code that you will be getting out, and this is the output. So once you set up a pipe, you send in a value like hello world, and you will get the vector out. So how simple is that? You are not doing any of the implementation of this transformer, pulling the transformer model, converting the text into a format that it can be fed into transformer model. Nothing is done by you. Everything is taken care by the pipe module itself. But yeah, you should understand what is going on internally, and I will try to provide the details in couple of minutes. But I would really suggest that you don't need to worry about how the internal works as of now. As you go into production, before you start working more deeply with this module, yes, you have to understand how Towhee works, and not just that. You need to excuse me. You also need to understand how Hugging Face models works. That is the main reason why I created these playlist where I talk about Hugging Face models, and in case of NLP task and vision tasks. You see, everything, it is an ecosystem. It's not done by one person or one team. It is done by various people working on various different directions, and with one objective, that making usage of artificial intelligence and machine learning models way more easier than currently it is. And I think these guys have done a very good job. Okay, the intention of talking to you about all these things is that why to use the pipe module. So you understood. I hope that you are convinced that the reason why you need to use pipe module. And let us start diving into the first node. The first node is a very simple node. You start working by creating. The first node is map node. Each of these nodes are explained in detail inside Towhee modules examples also. The difference that I am making in this video is that I am creating different variable names. In case of the examples that you might find in the internet, that too in the Towhee library, the only difference is that in case of that examples in Towhee library, you will see the output and input, that is input schema and output schema, will be having the same name. So this was extremely confusing for me, that I was not able to understand what is going on. Why to use a map with same input and output? What difference does it make? I was not able to understand that. Then I realized, okay, I need to play with it, and then I started changing the variable names. So and also I was trying to figure out a easier way to explain the pipe module. So pipe module is like a function. like a Python function, but yeah, with some kind of over additions. The implementation inside the pipe module is much larger than a simple Python function. So all these things I was thinking, and then I wanted to share it with you guys. So here you see the map module has this particular argument requirements: input schema, output schema, and function. Function, it can be a regular Python function or a lambda function. I hope that you guys are aware of what is a lambda function in Python. If not, do an internet search, you will be able to get a plethora of options or ideas from that. Here, the input schema is the schema in which you are sending in the data. That is called as input schema. The input schema can be a column inside the data frame. It can be a single integer or single Python variable, or it can be any kind of Python collection. How to work with these collections also depends on the nodes that is going to be used after that. In this particular pipe module map node, the expectation is that you will give a single variable, and that single variable gets mapped to a new variable using the Python function. Why I am saying single variable? Because the Python function that is going to work with map is having single variable only. If you give multiple variables, then lambda function cannot execute it. So for an example, if I take num, I am giving only num here, and if I try to execute this particular pipe function with a list, then what will happen is it will error out. So I will show you why is this understanding what I'm right now telling, that the input actually depends on the function that is going to act on it, is very crucial. This kind of understanding is new to many people. Even it was new to me also. When we write the function by ourselves, we will know the flow, the execution flow that goes on, right? Here you can see the execution flow, but still, if the variable names are same, it is extremely confusing. So once I made the variable names different, and once I started playing out, then I understood that, okay, so in case of pipe module, when I'm going to create a variable called num, I can send in a single variable. So for an example, I can send in a single collection, and then what will happen is that will be acted upon by this particular function inside if I am going to use map node, and then I will get an output. So after I execute this, it will create a P2 object, pipe object, and I am going to send in just a number 2 here. Okay, and after I send the number 2, I am going to create a data collection out of the result, and then I am going to show it. So output is 4. This is pretty simple, right? Now the question is, if I, instead of sending number 2, if I send 2,3, let us see what happens. You see it immediately errors out. Okay, it errors out with the what is the reason? So it is saying assertion error. So you see the internal test that is running for data queue object, it fails. So it is not expecting multiple variables inside here. Okay, let us actually try to wrap it around a list and send a list, and let's see what happens. Like this, when you experiment it, right? See, again, this is also erroring out. So you might be thinking, Kamal, I can actually send a list here, right? I can actually make a list, and I can try to send it through lambda function. But the lambda function has to implement it. It has to take this list, it has to separate it and work on it. You cannot directly. So in case if I am going to send the list, what I need to do is, instead of using a simple x plus 2, I need to say x plus 2 for x in sorry, I should not say x plus 2 here, I should say I plus 2, or you can actually use underscore also, but that will be very confusing. X, if I use this method, what will happen is, for an example, if I execute like this, so this will become a list comprehension, and then if I execute this, then the output will be a list. So you see, output is a list, and whatever data I'm giving, 2 plus 3, it is actually getting added. So I hope that you understand this particular logic, or else try to work with it and try to understand it. What I mean by work with it. So let us go back to the presentation. So whenever I come to the end of the presentation, I say this, that you have to practice a lot. And also I give you this particular slide where I say, where I give you a GitHub notebook and ask you to practice. Most of you guys have never still asked me what is practicing. So the practicing in a real sense is to actually play with it. Play with the modules, play with the functions, play with the various objects that is given by Python. And the Python library that I'm discussing about. So in this case of Towhee, I showed you that how to break it. So the practice is not about, understanding what is being told. It is about understanding what is not being told also. That is why you practice. When you are doing any kind of physical exercise, or if you are working with any new topic that you want to learn or master, yes, you have to understand what is being told first, but after that you need to actually try and break it. Then only you will really understand, okay, why it is being told this way. So I want to, till now I did not actually take this route, but in this video I'm experimenting with this kind of explanation so you guys can better understand what is going on. So I hope that you understood map right now very clearly. And also here I am showing the next step. So here I am taking flat map. Flat map is the next node. So in this flat map, by default, flat map expects a list. What the flat map does is it takes a particular collection. So it takes a dictionary, or it takes a data frame, or it takes any of the Python collection, converts it, has to be converted to list. You cannot actually send a direct dictionary or a data frame into the flat map. You have to convert it into list, and then you can send it to flat map. It will explode it into a tabular data. So I'll be showing it to you in a moment. It is better to show you rather than explain this to you further. So here in case of map I sent in a single where it is, yeah, in case of map I sent in a single Python variable. In case of flat map, I'm starting by sending a list, and you see once I send 1589 as a list, you will see the output is in a tabular column, tabular format, and the output, the schema. So the num in is the list that we have provided, which is having a length of 4, and the output, the num out, is the elements of the list multiplied by number 2, and it is created into a column. So this is called as flat mapping. So it takes in the list or the collection and converts and maps it into a column inside the data collection object. Where it will be useful, I'll be showing it in a couple of minutes. What I want you guys to further practices is that try to break it and try to get some errors out of this particular pipe and see what you can learn from it, as I showed it to you in the map node. Next is the filter node. This is one of the nodes that I am getting error currently. Even though I have understood, I am following all the processes that is shown in the Towhee module, I am getting the error because what is happening is so here I will explain to you what is going on, but still it is erroring out. I am taking the input. The input is going to be list because I am going to do a flat map. So first I am going to do a flat map. So flat map will create this kind of a column, and after I create this kind of a column, I am going to filter that column. So what I am going to do is I am going to filter the column based on the lambda function here. So the lambda function, when you are going to use filter, should be x is equal to greater than 10, right? I am going to do so here in case of flat map, I don't need to change this. I'm sorry about that. Flat map is going to be the same implementation like how I did at the top. So we will be getting the output 2, 10, 16, 18 if I give an input of 1589. But here what I'm trying to do is I'm taking the same flat map implementation, but after doing the flat map implementation, I'm doing the filter implementation. In the filter implementation, what I think is happening is that this filter, there are two kinds of filter implementation. One is inside Towhee module itself. So let me go up. There is one in the Towhee module, and there is one inside Towhee.dc2 module also. There are two implementation that is coming for this filter. I think there is some kind of a namespace confusion here. That's why it's erroring out. So in the case of filter, I need to give a function. This particular function is a lambda function again, which checks the condition. And once it checks the condition, it only outputs the rows that are matching this condition. The rows that I'm talking about is this rows 2, 10, 18, 16, 18, these rows. Only those rows which is having number greater than 10 in the filter column num will be sent out. However, this is erroring out. So I am working on this particular concept till now, but the errors I couldn't solve it. But still, I'm sharing it with you guys so that you can understand what is going on. And even when you are facing error, also understand that you understand how or why that error could be created by reading the error outputs. So let us take for an example, there is an error output that comes out, and we see that the node lambda failed, and it says that lambda function takes one position argument but 3 were given. And if you go here, you will see that I am still giving only one value here, so I am only giving z value. So what is happening? So this is something that I'm still exploring. So let me get back to you once I have some feedback. If you guys have some clarity, do let me know in the comment section. Next is we have window function. So now I hope that you guys have understood what is flat map and map. We will go with window function. Window function has this implementation: input schema, output schema, size of the window. So the size of the window is 3 that I have provided here, and the step is, so if I have 1, 2, 3, 4 up to 9, and I have added 2 more numbers, 15 and 75, just to give a randomness to the list. And if I take a window, so the size of the window, first window will be 1, 3, 4. Sorry, the size of the window will be 1, 2, 3, and then it will step 2 steps. So it will start from 3, 4, 5 next. So that is what this window function is all about, and it will do the calculation, and it will, in this case, what it does is it creates a new list. So once I give 1, 2, 3, 4, 5 till here, it will create the num values 2, 4, 6, 8, 10 that is getting created from this flat map. You see this flat map? This is how this 2, 4, 6, 8, 10 is getting created, and then this window function creates this column. So the window function creates this column by mapping this 246 into this particular lambda. Okay, and it is creating a window. So you see the first cell has 4, 8, 12. How is this 4, 8, 12 getting created? This is created because I am having a window of size 3, and it is stepping every 2 elements. Once you practice with this size, you will understand how it changes. So let me take for an example, if I take 4 here, and if I execute this, you will see the list that I am getting created is 4 in number here. And this is what I am trying to say. When you practice, try to understand intuitively. Yes, theory is also important, but understanding it intuitively is more important. And this is a little more complex topic called time window. In case of time window, what happens is you might have data sets which involve time, and you might want to club or cluster the data based on the timestamps. You must have come across group by option in pandas. You might have, if you have worked in Spark or PySpark, you must have come across various group by options inside the Spark also. In case of Towhee, there is similar option, that is window. So that is what you are seeing here. But in case of window, it is much more free. So you don't need to have a particular category to cluster it. You can arbitrarily cluster on a particular window size. And same way, if you want to work on a timestamp and you want to do some way of doing a window function on the timestamp, then you can use time window. So I'm not going to deeply explain about this. Try to intuitively understand this particular module, time window, and if you have any questions, do let me know. But this implementation is actually important. What is happening here is that till now we were working with only one input, correct? But in this case, there is going to be 2 inputs. Excuse me, just let me go up because I skipped it. This is a time window. There will be 2 inputs. That is num and timestamp. So there are going to be 2 inputs and there are going to be 2 lists. So this is the data list that is coming in, and this is the time frame that is coming in. And these 2 lists are going to be mapped here separately into num column and timestamp column, because you are giving it as a list. It has to be converted into a format that can be worked upon on the data collection, worked upon by the pipe inside the Towhee module. And after that, you are going to implement the time window. And this time window has input schema, the output schema, the timestamp column, size and step. So the difference, I just want you guys to try to find out the difference here. What is the difference of using timestamp column and not using it in the earlier window function. Try to find that out. That will actually help you to understand intuitively why you need to use timestamp column. Rest of the things are very similar, guys. It's not very different from the window node. This window all will take the entire data that is provided to you and it will create a single output. So let us take this. I am going to say 1 2 3 4 5 1 2 3 4 input, and you will see that 2 4 6 8, this is the flat map that is getting created. And in the window all function, okay, so window all function is used when you are trying to consolidate, but here I am not consolidating. I am further using a similar kind of a lambda function, and I am trying to create a list out of here. So what you guys can do is, instead of using a list comprehension here, you can try to use a way where you can do a sum of this entire. So for an example, let us do this. So this is very important. Let me do a sum of the list, and let me show you what happens. So if I'm going to execute this, finally the output will be 40. So this is actually more confusing, right? How did 40 come? So the 40 came because I did a window all function, and inside the window all function I'm using a lambda, which is using the sum on top of this particular list comprehension. So this is actually more complicated. So that's why I did not actually use the sum in my notebook directly, because if a new member who is trying to learn about Python comes across this kind of a complexity, it will be difficult for them to understand. So that's why I left it with the list comprehension itself. I hope that you guys can understand what is going on in this particular step, or try to explore by the way I showed it to you right now, by using a more simpler implementation. You might want to remove this multiplication here and see what happens. That will actually show you show you what I am trying to explain in a more easier fashion. Okay, so that is about window all. And finally we have concat option. Till now, all this pipe, whatever you have been seeing, it has got multiple steps, correct? So it starts with the input, and you see there is flat map. We are doing some window operations, we are doing some aggregations or consolidations, and then we are taking the output. We can have multiple pipes like this, which takes different outputs, and then we can concat it and get a final output. So here you see that pipe 3, we have actually 4 pipes. So it starts from pipe 0 and it goes up to pipe 3. Pipe 0, that is the first input pipe, has the input A, B, C. And pipe 1 does some activity on A. Pipe 2 does some activity on B and C. So understand this flow very clearly. I can actually show you as a picture the Towhee examples. If you go to Towhee documentation, you will see the examples there. However, I want you guys to intuitively understand this. You have to play with this a bit. Here you see that the second pipe works on two variables, and it is mapping those 2 variables using the lambda function here. And this is the reason why I wanted you guys to play with the map function. In case of map function, I told you that we are working with single variable. This is single variable, right? Now try to see whether you can use the same map function with multiple variables and work with this lambda function. If you can understand this, then understanding pipe function will be much easier. Pipe concatenation will be much easier. And once you do this concatenation, you will see the output is like this. It is in the data collection type format A, B, C, D, E, and you are getting this output. So for an example, I am giving 1 2 3. So the pipe 0 actually converts this 1 into 2. So this 1 variable is converted to 2, and it is getting mapped to D. So this is the value 2 that you are getting here. And in case of B and C, that is 2 and 3, it goes into goes into pipe 2. And here 2 and 3 gets subtracted. So 2 minus 3 is minus 1. And that is getting attached to E. That is what you are seeing here as E. And pipe 3 concatenates both pipe 1 and pipe 2. So pipe 1 and pipe 2 is getting concatenated. All the data that you are getting out from these pipes, A, B, C, is the input that you give, that is directly taken as output. And the value D is coming from pipe 1 and value E is coming from pipe 2. and all the values are printed here. Try to play with this and try to understand this, because we are going to supercharge it right now. What we are going to do is, there is a, if you have seen my earlier videos, you can work with images, you can work with audio, various modalities inside Towhee module. And one of the processes that we can do is that we can take an image, we can decode the image into numbers. So once you send the image, so this particular image I already shared to you how to find it out in my GitHub repo, and you can convert these images into matrices. So this is a single image, but what if you want to do it for multiple images? So in that case, you can create a pipe and you can map this particular function like this, and you can actually take an output. So you see the pipe function implementation, right? And here we can send a single input like this, and you will get the output like this. So you will get the image output also, you will get the decoded value also. So both of these things you can see it. This is how you see the name. The name here is the data that you are sending in, that is a path, and the image is getting decoded, and you are seeing the image here. Okay, it's almost like pulling the rabbit out of the hat. That does not stop there. The next step, what we are going to do is, we are going to send a list of images. So you can actually upload the images here by using this upload function, and you can practice this. So you can create a list out of these, and you can do multiple things. You are not just going to do an image decode, you are going to go one step further, and you are going to pull the ResNet model, the Facebook ResNet model, into this notebook. This notebook can work with ResNet model, so should not be an issue. You see that it is getting pulled from TIM pipeline, and it starts working with the ResNet model in a moment. And after it pulls it down, it works through these three images, and converts and gives the embeddings also. So you see the embeddings here, you see the image, you see the embedding, and you see the URLs. This is the power of pipe. Okay, it doesn't stop there. Let us go further. In this case, I am going to compare two different things. So that is the reason why I am going through this. First of all, I am creating a data frame. I am importing pandas as PD, and I am creating a data frame out of these URLs. And I am sending this data frame values as to list. This is what I was telling. So you cannot directly work with the data frame in this pipe module, and you have to convert it to list, and then you have to map it, and then you have to take the output here. So you see this particular step. This is what I am showing you. So for an example, if I do a test pipe, so this is a test pipe I'm sharing, and if I send this image df, so if I send the image df in this, so the output will be, okay, so the output will be 2VQ, so you cannot use that. So I have to use the data collection object. I have to send it through this, and I have to show, then only you can see that. You'll see that it gets mapped to this is the output that you get. So it whatever data and whatever function, whatever data frame I am creating, it's converted to list. The values are converted to list, and then it is moved through the flat map node, and you get this output. And the same way, if you are going to work with, so this is what I am doing it here, and I am showing it to you guys. You can actually work with data collection also directly. So in data collection, there is something called as 2DF. So you can convert the data frames, the pandas data frames, into data collection, and you can work with similar kind of modules like map modules and flat map modules. In case of data collection, you cannot actually change the column names like how you are changing here. So I am starting with the input URLs, I am converting that URLs to images, embeddings, and again making some outputs at the final step. All these things are little cumbersome when you are trying to use data collection object. So if you guys have used the earlier one, you will understand. I will be also exploring this particular step, the last explanation I gave it to you, more detail in the next video. So where I will be explaining how to ingest data, ingest text data from the data frame into Towhee module, work with pipe module again, and then get the embeddings out. And also an addition, I will also try to discuss with the vector stores that we can discuss that we can use with embeddings. So all these things I will be discussing in the next video. I hope that you understood the pipe module and the difference between using pipe module and data collection module. Initially, it takes a little bit of a practice for you guys to understand the difference and how to use pipe module in reality. So I will be also giving you some examples in the next video. So stay tuned for that. And as I always say, practice a lot, guys. The more you practice, better you'll understand. And see, I'm not enforcing any kind of a practice routine here. As you saw, practice should be a playful thing. The more you play, the faster you understand and better you can solve your problems. You see the sequence, right? Play, master, and better solutions. That's the output that we are looking for. And I hope that you like this content. Do share it with others and subscribe to my channel so that further videos will hit your YouTube dashboard directly once it gets uploaded. With that said, I would like to take a leave with 4 words as usual, with practice, 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 practice. See you guys. Have a great time.